Thank you everybody for attending. My name's James Dunlop. I'm a senior engineer with the Carbon Trust, and I'd just like to welcome you to this Green Business Fund webinar on debunking energy myths. So just going to go through a brief introduction and then look at some common energy myths and the truths around them as well. And as Susan says, there's an opportunity for you all there in section 3 just to put forward your own energy myths, and we'll pick them up at that stage just to talk them through. So if you do have questions that come up or other aspects that you would like to discuss, if you put those into the questions pane on the webinar, we'll pick those up then in due course. And the last part of the presentation will then go on to support available through the Green Business Fund. So I suppose that the aim of this webinar is really to throw light on common myths about energy and energy use, and go through some of the fundamental energy principles. We'll also discuss tried and tested energy saving techniques and technologies that are available, and provide more details on support that's available through the Green Business Fund. So, I mean, I suppose it's a bit of a light-hearted topic, but in many cases, uncertainty over energy efficiency measures can lead to inaction, can lead to companies and individuals avoiding taking forward measures, which can mean that opportunities are missed. So it is good just to clarify some of these issues, and hopefully that'll encourage people to take action on the strong energy efficiency measures. So just to give you a bit of background on the Carbon Trust, we're a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. We provide advice like this to businesses, also to governments and to the public sector on low carbon opportunities. We also provide carbon footprinting to measure and certify the environmental impact of organisations and of products and services. And we help to develop and deploy low carbon technologies and solutions. There's lots more information on all of this on our website. So we'll just go straight into the energy myths and truths. First one, I suppose, is something that comes up from time to time, and often people will say that having the heating on low for longer is better than having the heating on high for a shorter period of time. So that essentially is a myth. In effect, neither is better. So leaving the heating on low will waste energy when it's not needed, and also overheating a space will waste energy by heating to a higher temperature than required. So it's important just to have the right balance there, and it really comes back to the fundamentals. And that is very basic, and apologies maybe for oversimplifying this, but it comes back to the very basics of what energy is. Energy essentially is power times time. So the longer you have a system on, the more energy that's going to be used, and to a certain extent as well, the higher the power level is, the more energy that's going to be used as well. So thinking back to those common principles it is often the easiest way just to think of some of these issues that arise that maybe lead to uncertainty around energy use. So in terms of heating, really good practice for heating would be a set point of 19 degrees C. And for every 1 degree C reduction that you make in your temperature set point, you'll typically see an 8% saving in energy. Good use of time controls as well will be beneficial to make sure that the building is only heated when it's required, and good use of thermostatic radiator valves can mean that areas of the building can be switched off when they're not needed. In addition, through the winter season, people will often preheat buildings. That should be applied cautiously, and the use of direct weather relaxation could well be beneficial for larger systems to ensure that that's optimized. So on the coldest days, the heating comes on earlier, but if there's a milder period, then the heating maybe doesn't need to come on until just before it's occupied. So balancing that out will be beneficial. The second question we have here is LED lighting can cut your lighting energy use by more than 70%. Well, that's actually true. So that is the case in many modern LED solutions. They're providing power levels of just 30% of traditional incandescent and some older fluorescent systems. So there's significant savings to be had through going to LED lighting. Next one here, due to the energy required to start older lighting, is better to leave it switched off rather than switching it on and off. That's something that comes up from time to time, but that is a myth. So essentially, the energy can be higher just at that very brief period of startup, but the duration of that is so short that it can be considered negligible. If we look here at the inrush current for tungsten filament lighting, it is much greater at the very start at switch on, but that lasts for such a brief time, less than 1 second, leading to negligible energy use. So even leaving the lighting on unnecessarily for a minute or more will use more energy than switching it off and then back on again. So the inrush current really comes down to what happens in the electronics of the lighting. So often there's capacitors or small transformers that need a level of energy just as they're switched on, just to charge up. But once that period's passed, then they stabilize at a much lower energy level. So typically that's something that is said from time to time, but in effect, making sure that the lighting's turned off is the best policy. And coming back to that aspect on LED lighting, the energy performance of LED lighting has now far surpassed that of conventional solutions and can be used for pretty much any lighting project. There's a strong business case to replace conventional lighting with LED, and that applies particularly where you have long hours of operation. But even if your operating hours are 2,000 hours per year or more, you should get reasonable paybacks, certainly in around 5 years or less. And as well as going to LED solutions, the use of automatic controls such as daylight dimming or presence detection can make sure that the lighting is switched off when it's not needed, and it'll avoid any unnecessary lighting operation. Okay, this next one's interesting. An air compressor uses no energy unless there is a demand for air. Well, that is actually a myth. And as it happens, the energy demand of a compressor can be significant when it's operating off load. So despite not providing air actively to a compressed air system, it'll still be using quite a large amount of energy in standby effectively. So as we can see here in this chart, offload power can be as high as 60% for older fixed speed compressors. So this example shows an 8 kilowatt compressor, which would be operating at in around 4.8 kilowatts when it's running offload. So if you're to take a typical factory environment, maybe hours of operation of 2,400 per year, it could be running on load for just 800 of those hours, i.e. a third of the time. So you may be using it 4 or 5 hours out of 10 or 12 a day, but it'll be sitting off load for the other 2/3 of the time, and that will use significant amounts of energy. You can see there the energy use in the year is actually higher offload than it is onload. So the onload energy use just at the very bottom of the slide is 6,400 kilowatt hours, and the offload is 7,700 or thereabouts. That applies in particular to fixed speed compressors, which are modulating simply between on and off load. So that's fairly common, and there's a good case for making sure that the compressors are switched off when not required. That'll happen generally at the end of a working day anyway. Most companies will make sure that they're doing that. But switching it off in other periods, maybe whenever there's a lunch break or a periods when there isn't production during the day, will be beneficial as well. The other option is to look at a variable speed compressor, which can modulate its output to meet demand and also sits back at much lower energy use when no air is required. And I suppose simply as well, when we're on the subject of compressed air, one of the biggest issues there is around leaks. Leaks can account for as much as 30% of compressed air costs in the first place. So if your compressor isn't operating offload, maybe that's down to leaks in the system. So leak detection and repair should always be prioritized. This next one, again, I think it surprised me. UK grid carbon intensity has reduced by more than a third since 2015. Well, that is actually true. We've seen a big drop in the carbon intensity of grid electricity. So it's dropped from 462 grams back in 2015 per kilowatt hour to just 283 per kilowatt hour now in the latest figures from DEFRA for 2018. And what that means is that electricity is a more attractive source from a carbon perspective for energy systems and is being used more in the likes of heat pump solutions. And on that, there's another potential myth. If you set the air conditioning to 16 degrees C, it'll cool much quicker than it was set to 23 degrees C. Now, often the temptation is in the height of summer to drop the temperature level right down on air conditioning systems to make it as cool as possible. But this is actually a myth as well. In essence, the air conditioning system can only cool as quickly as it is capable, and we would recommend a temperature set point closer to 23 degrees C for cooling, which will take the hottest temperatures away without using excessive amounts of energy. So yes, so your air conditioning system will only cool as quickly as the unit is capable. Cooling set point of 23 degrees C would be recommended, and that should provide a comfortable working environment in the office space. The other factor, though, as well, I suppose, as air conditioning becomes more and more prevalent, is it needed at all? So I've taken some weather data here. It's from a fairly arbitrary point from High Wycombe in England, just somewhere relatively central to use as an example here. But looking back at Met Office data for 2004 to 2010, you can see below in the chart the maximum average daily temperatures across the months of the year. So there's only 2 months of the year there, July and August, where the temperature is in excess of 20 degrees C, and you might start to think that the cooling is needed. But looking at alternatives in terms of good ventilation strategies could potentially avoid the need for air conditioning at all. Or if you do have it installed, it's maybe a case of using it sparingly then just through the hottest of those months. So the next one we have here is IT equipment fitted with standby mode uses little or no energy when not in operation. This again is a myth. It is surprising though, because I suppose technology advancements have led to IT equipment operating with good energy performance. But while some IT equipment uses very little energy in standby, networked equipment that has developed more recently within the last sort of 5 years can have significant consumption. This is something that has been looked at through European legislation and through EU eco-design requirements. So since 2009, devices must switch into a low power mode after a reasonable amount of time. So that certainly helped. From 2013, that was set to a lower limit of 0.5 watts in standby. But really, since about 2010, more and more networked appliances have started to come on to the market, and they can use higher levels of energy. So that again has been tackled, but only relatively recently. And since January 2017, networked devices with standby capability must now consume 3 to 12 watts, depending on the exact product type. So that compares to a previous limit that existed prior to 2017 of 20 to 80 watts for network devices. So some of your networked printers or photocopiers could be using significant amounts of energy in standby mode. So looking at the graph below, if you look at the middle bar in particular, that represents old networked equipment with the higher standby limit. And assuming that it's in a typical office being used 9 to 5 sort of office hours, but being left in standby outside of that, it could be wasting as much as £63 per year. The new networked standby limit will improve on that, but again, it's only come into force back in 2017. So if you've equipment older than that, it could be the case that it's using significant amounts of energy whilst it's not required. Okay, this next one here, we're saying a well-insulated building can reduce heating energy requirements by as much as 2/3 while still providing the same level of comfort. So it's a big drop there, but that is actually true. So effective insulation and building air tightness makes a significant difference in the thermal performance of a building. And as such, when it comes to any extensions or new builds that you might have planned, it's important to look at the levels of insulation and air tightness and to go to the maximum level possible, even if that's in excess of building regulation requirements. Another one here, the highest area of heat loss in a building is typically through the roof. That is actually a myth. So there can be higher areas of loss in typical buildings, quite often air infiltration and also losses through windows can represent higher levels of heat loss than through the roof of a building. So what we're saying here really is that whilst the roof of a commercial building does account for significant levels of heat loss in around 22% in this typical example here for a commercial building, there are other areas, the likes of windows, if they're single glazed or not well installed, they can lose as much as 26%. And indeed, the level of air infiltration is higher again. So yes, loft insulation is important, but it's worth looking at the full building envelope to make sure that your building is performing well thermally, especially through the winter heating season. Now, some of the improvements to upgrade insulation or to improve building air tightness can be a long-term return in investment, but at the same time, depending on your plans for the building, it could be worth doing to put you in good stead into future years. Okay, another one here then, an hour's worth of energy from the sun could power the earth for a year. Sounds incredible, but is actually true. So basically the level of solar energy is such that we're in effect only using 1 hour's worth of output from the sun in any given year. The next one here, solar panels are expensive and don't save much energy in the UK. That is something that is a perception amongst some people that solar panels maybe aren't achieving that much, but that's really, I think, a myth now that the technology is well established. We've seen the price of solar panels drop by more than 50% in the past 10 years, and it can provide significant amounts of energy as part of an overall energy management strategy. So as we said there, the price has dropped dramatically. You can see that on this chart. Now this is for the domestic sector, but at the same time, it shows the same sort of principles that's happening in commercial installations. So you can see there that the price for a 4 kilowatt peak system back in 2010 was about £20,000, and that has now dropped significantly below £10,000. So for commercial systems, what we're seeing now is rates of £800 or £900 per kilowatt peak for new systems. So that makes it relatively effective in terms of its benefit relative to its cost. And again, the aspect that there's not much energy to be generated, again, that's not the case. You can see the sort of yields that we're getting here across the UK. Typically, we'll see 800 to over 1,000 kilowatt hours per kilowatt peak, depending on the exact location in the UK. Now, the solar industry has been underpinned by feed-in tariffs pretty much since 2008, 2009, that sort of level. But that will come to an end next year in March 2019. So again, if you do have a plan in place to put in a solar scheme, it's worth keeping that in mind. If you can have it installed before then, you will benefit from the feed-in tariff. Beyond that, though, the case is still reasonable. They're with competitive prices, you should see a payback period of potentially less than 8 years, where you've got good solar yield and you're offsetting grid electricity use at your site. So it is an option. And again, what we'd always emphasize would be it's part of the energy efficiency hierarchy as such. So really the place to start is through reducing your demand, then looking at bread and butter energy efficiency measures, certainly on heating and on lighting. And then from there, there's the option to look at renewables and other low carbon technology. They tend to be a little bit more expensive, but at the same time, as we've seen in those previous slides, there is still a business case for investment in the longer term. Okay, there's another aspect as well here in the bigger scale. We're saying here that the UK grid has operated for more than 1,000 hours this year without coal. You probably know this already, and it is true. It has been in the headlines, and there is increased use of renewables and also gas within the UK grid. So that has meant that the coal has been used less and less. And as you can see here in the following chart, taken from the Guardian there was over 1,000 years in 2018, and that was up to the 13th of July this year. So potentially, going into next year, that could be higher again. And I think it's important to recognise as well that we have seen significant carbon reductions across the UK. We've seen recently figures from 2017 have shown that we've 38% reduction, 30% less carbon emissions now than we had in 1990. which is a great achievement, and it actually takes us back to the same levels of carbon emission as 1890. So it is heading in the right directions in many cases. But again, looking at reports this week in terms of carbon intensity in the atmosphere, it's reaching all-time highs, and so there is still a lot more to do. Okay, so that concludes my energy myths section. So now it's over to you if you do have any queries or myths of your own that you want to share.
We've got one myth here that someone wrote. Server rooms have to be kept cold to avoid the machines overheating.
Well, yes, that's a good one. Thank you, Susan. And I think in that case, I suppose it comes back to the same principles as our air conditioning. So, in essence, it's often the case that the server rooms are chilled down to levels of maybe 16, 17 degrees. But we've often looked at this for clients, and we've seen that actually the equipment is capable of operating at much higher temperatures quite safely. So the guidance would be a temperature of around 23 degrees C would be satisfactory. And again, that's something that can be easily changed in any business that is over chilling their server room. Just simply by moving that temperature set point higher, it means that the air conditioning system will be operating to a lesser extent and will use less energy. Thanks.
Okay, we've just got another one here. Individual equipment is capable of running at 50 degrees Celsius, but is more efficient when running at lower temperature.
Is that in relation? That's potentially in relation to the server equipment. Yeah. So I suppose you don't want to allow your equipment to run at higher levels than needed. But I think in essence the ASHRAE guidance would suggest that pretty much all levels of equipment up to enterprise servers is happy effectively running at 23 degrees rather than having the need to operate at much lower temperatures again.
Okay, why does a dryer make a compressor more efficient?
In effect, I don't think it does. The dryer is effectively removing moisture content from the compressed air and is improving the air quality. Now, depending on your industry or your use of compressed air quality can be very important. So having dry, moisture-free air will be beneficial. It will be a slight energy penalty, but again, just looking at the criteria for your quality of air and matching that to what you're providing through dryers would be the best way to improve efficiency of the overall system.
Thank you. Another one here. Would you recommend evaporative cooling? I've heard it's not as effective as traditional air conditioning.
I think I would recommend it in certain applications. In essence, what we were looking at on the chart for temperatures in the typical example of High Wycombe, we're seeing very short periods of the year when cooling is required. So if you were to use evaporative cooling in a situation like that for somewhere like an office building or somewhere that cooling wasn't completely critical in, then evaporative cooling could work well for you. There is a limit once you get to the very highest temperatures in terms of external air. It maybe won't chill as effectively as a mechanical air conditioning system, but in the same time, in the right application, and for the right building type, I think it could be well applied.
Okay, we've got one more here. Electric water heaters are not using much energy if switched on unless you turn on the hot water.
Yes, well, I think that is largely true. Electric water heaters under sink small units, they certainly shouldn't be using much energy. They'll be keeping a very, very small reserve of well insulated water hot, and we'd often see them as a good alternative to large storage cylinders. So typically you would see in some older factories or businesses, you'd see a gas-fired system with a large hot water cylinder used for hot water. That would tend to have quite high losses. It could be storing potentially 90 or more liters of water. And even with a reasonable amount of insulation, it'll have quite a high loss. The undersink point of use heaters tend to provide hot water more efficiently overall in comparison to that. So yes, you'll get a small amount of loss from that slight storage of hot water so that the water's hot when you turn the tap on. But often that can be a better scenario than the alternatives.
Okay, I think that's all the questions we have for the moment. So back over to you, James.
Okay, thank you, Susan. And thanks everybody for putting forward the questions there. If there is anything further that comes up after the webinar, feel free to email them through and we can pick them up afterwards. Okay, so just to conclude then, I'll provide some more information on the Green Business Fund itself. So in terms of what is the Green Business Fund, it's a scheme operated by the Carbon Trust and it's aimed to provide improved sustainability and energy efficiency for SMEs in particular. So it currently serves businesses in England, Scotland and Wales, operating primarily so far through 2017 and 2018, and that applies in particular to the capital contributions. We do have funding available now, but that's likely to last maybe for the coming weeks, and then beyond that, we probably will have exhausted the financial support that we have there. So the fund not only provides those capital contributions, but also provides advice, training as well. And there's hope that in the future there'll be scope for it to potentially continue in the UK or to expand internationally should additional funding be made available. So again, there's more on the scheme on the website. So again, it applies to England, Scotland and Wales. It's suitable for SMEs, also for schools, sole traders and charities. And in terms of how we're defining an SME, you can see it there. We're essentially looking for organisations with no more than 250 employees or with those financial criteria there. So it needs to meet two of the criteria on the page there. We're providing workshops across the UK. You can see a list there over the coming months into 2019 as well. So the 2-hour workshops provide more information to help businesses understand energy consumption and to identify no and low cost measures. So those are aimed at companies with less than 50 employees. And as well as that, we can provide direct advice to businesses. So we can provide opportunity assessments either remotely or for companies with higher energy expenditure through a site audit. We'll provide a brief report which outlines key energy efficiency measures, the associated costs and the associated savings. We can also provide implementation support to help take recommendations forward or companies' own projects forward, and that will facilitate a tender process. Will allow for review of proposals, examination of whole life costing, and really help you determine the best solution for your business. The capital contribution, as I say, is coming towards the end of its availability, but where available, we can offer 15% towards the cost of energy saving equipment. That applies up to a maximum of £5,000 with a lower limit for the smaller projects of £750. So that would apply to a £5,000 project as a minimum. Can't be applied retrospectively, so it's important to get your offer from us before placing your order. In addition, we have other services such as the Virtual Energy Manager service, the technical webinars such as this one and others, and we also have a host of publications available on the website. Which again give information across a range of technology types. There's an organizational carbon footprint calculator as well, which has been developed recently. So that allows, again, small businesses to pick that up, to be able to develop their carbon footprint, and that follows a GHG protocol and it gives you step-by-step instructions just to go through the process. So that pretty much concludes this webinar. Thanks very much for attending. And if you do have any questions just on the Green Business Fund, feel free to send those through now, and otherwise that's us concluded. Thank you.